we have got the statement of modern periodic table. What is the statement of modern periodic table? Properties of elements are periodic, very good, are periodic function of their atomic number. And this statement, or sometimes it is called as law, and atomic number is written as Z, and atomic number is equal to number of protons. And here in modern periodic table, one thing is there. So do you remember the limitations of Mendeleev periodic table? There were 3 that I will discuss in the next class. But you remember that there were 3 limits of Mendeleev's periodic table. And these 3 limitations are taken care in this. This is the point that you have to remember. Now, let me tell you about the story that you have to remember. This is periodic classification. Periodic classification is meaning what? It's a classification which is repeated in a period. That we will see later on. It is a classification which repeated in a period. So when you go to the supermarket, what do you find? You find the racks over there. And one particular rack or one particular shelf is devoted for particular product. Let's say one rack entirely is devoted for the cosmetics. Then on one shelf there will be soaps. Another there will be shaving cream. On the third there will be shaving blade. And so many things will be there. So that will be the one type of the rack. And then in some other rack, if you go, you will find different things. You may find all cakes will be there in one shelf. When you go at some other places, you will find all vegetables, all grains will be kept in that particular region. Why it is done? It is classified properly and kept as it is. If it was not classified and kept in this manner, what would happen? Everything would have got mixed and it would have become very difficult to search for the product and leave the product in the supermarket. In the similar fashion, in chemistry, there are so many elements. How many elements are there? So far,
118.
118 elements are so far discovered. Now, this is old one. New, as per the latest one, there are more than 118. That was when the book was written, or your textbook was written at that time, that was 118. But for time being, you have to know only that there are 118 elements. Now, these 118 elements, if they were not classified properly, then there would have been mess. Studying the chemistry would have become very difficult. So when periodic classifications are available, elements are properly classified, that is why it becomes easy. And I want to tell you, if you remember the periodic table of all 118 elements in the increasing order of their atomic number, then wonder can happen. You can remember whole of the chemistry well, because the characteristics, behavior of elements and their compounds are based on this. So based on which period and which they lie. So whether they lie in particular group or particular period, that can be located, and the behavior in particular period or particular group is similar. So you can find out what is the behavior. So that is the importance of modern periodic table. Now you imagine that you have gone to the supermarket and you find different elements are kept in the supermarket. So please listen this story carefully. So here, then you will find there will be different racks kept. This is the first rack. Then at the first rack will have 1, 2, 3, 4, 5, 6, 7 shelves. Let's imagine that it has got 7 shelves. This is one shelf. Then second, third, 1, 2, 3, 4, 5, 6, and the last one is 7 shelf. And then adjacent to it, there is one more rack kept. That rack has got 6 shelves. 1, 2, 3, 4, 5, and 6. And then adjacent to it, there are racks of 4 shelves only. So 1, 2, 3, 4. So this is a rack of 4 shelves. 1, 2, 3, 4. Then again 1, 2, 3, 4, 5, 6, 8, 9, 10, 11. There are 11 racks of 4 shelves. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. There are 11 racks with 4 shelves. This is first shelf, this is second shelf, third shelf, and the last one is the fourth shelf. And then there are 5 shelves with there are 5 more racks with 6 shelves. So 1, 2, 3, 4, and 5. So you see here, these are the shelves: first, second, third, fourth, fifth, and this is the last one, 6. And there is one more rack with 7 shelves. So 1, 2, 3, 4, 5, 6, and 7. So I will name this shelf from top. This is shelf number 1, shelf number 2, 3, 4, 5, 6, and 7. There are 7 shelves in this rack, and items are kept in each of these racks. There are total 18 racks. When you enter the supermarket, you imagine that you have entered the supermarket, and in the supermarket, items are displayed in total 18 racks. First rack has got 7 shelves. Last rack, that is 18th rack, has got 7 shelves. Then the second rack has got 6 shelves. Then 13, 14, 15, 16, 17. That is, except the last one, the previous 5 racks has got this 6 shelf, and remaining, that is from 3rd to 12, it has got 4 racks only. And items are kept in these racks. Different items are kept in these racks. So what you have to remember first is that there are total vertical 18 racks, and there are total horizontal shelves. They are 7. Then one more thing you have to remember. Regarding the number of valence electrons. What are valence electrons? In the outermost shell. That is, in the outermost shell, what are the number of electrons? That is called as valence electrons. And the shell, which is the outermost shell, that is called as valence shell. Now, here you have to remember something like this. So let me draw it over here. Central will be the nucleus, and here there will be one valence shell. In the first one, in the second shelf, there will be two valence, two shelf will be there. You see, there are two shelves, and in this third one, there are three shelves. Then for this fourth one, there are four shelves. 1, 2, 3, and 4. There are four shelves. So similarly here, there are 5 shelves. Then 6 shelves are there, and 7 shelf is there. So as the number of shell, when you go down, increases, like that number of shells accommodating electrons inside it, it goes on increasing. So what you have to remember is, in each rack there are placed some rings. In the first rack, ring with one, so with one ring is kept. In the second shelf, item with 2 rings are kept. In the third shelf, item with 3 rings are kept. In the fourth shelf, item with 4 rings are kept. And in the fifth, 6, 7, items with 5 rings, 6 rings, and 7 rings are kept. You have to just remember like this. So I will decode it later on once I complete the story. The story is like this. When you enter a supermarket, you will find 18 racks. First rack has got 7 shelf. Last, that is 18th rack, has got 7 shelf. The second one, and 13 to 17 has got 6 shelf, and all racks from number 3 to 12 has got 4 shelf. In the first shelf of each of this rack is kept items with 1 ring, second shelf item with 2 rings, then 3 rings, 4 rings, 5 rings, 6 rings, and 7 rings, like that. What are the number of electrons in the valence shelf? What are the number of electrons in the valence shelf? It is given by what formula? So number of electrons.
Sir, 2n square, I guess.
Yeah, in shell is given as 2n square. That is maximum number. So that means, please tell me, in the first shell, how many maximum number are there?
2.
Yeah, it is 2. Then sorry. Then second,
8.
yeah, 8. Then third,
18.
yeah, 18. Third is 18, but what we have done, what we'll do is, it is 18 maximum. Okay. Then fourth, 4 square is 16. 16 into 2 is,
32.
and so on. These are the number of electrons are in each shelf. Then we have to remember that in the first one, the valence electron, I will write valence electron. In the outer ring, there will be 1 electron. So here in this, valence electron is 2 in the second. In the third one is 3, 4, and so on. And in the last, it is completely filled. So that means you imagine what you call that money kide manta me English in. So you have got I'll tell you. So marbles are there and marbles are kept.
Phrases, sir.
Pardon
Phrases.
me.
Phrases, sir. Phrases.
Repeat. Okay. Anyway, आम्ही कोंकणीन मणी म्हणटा तर रिंगांनी मणी घातल्या अशें इमेजीन करा. So oh yeah, let me check. It is phrases. Okay. So here I will tell you. In the first one, the outermost, let's say this is the outermost for the first one, there will be one. Here, there will be one here, there will be one here, there will be one, and so on. The outermost orbit or the outermost ring has got one electron like this in the first shell. Outermost ring has got one electron in the first rack. All the shell rings are there in the outermost ring. In each of these shelf of this rack has got one electron. Similarly, when the elements are there in this or items are there in the second rack, the outermost ring has got two electrons. Here, outermost ring will have 3 electrons, 4 electrons, 5 electrons, and like this. That means in each cell, the ring in the outermost or the outermost ring in this each of this cell is 1 electron, 2 electron, 3 electron, and like that. So far, what you have to remember, this story you have to remember till the day of examination. No need of revision, nothing like that. But please do the revision. But even if you go directly with this story, you will understand the question and you will get the answer very easily. So the next thing what I have told you is, the second thing I have told you is the number of rings in each cell. And now I have told you number of electrons in the outermost orbit in each of the rack, irrespective of what is the shell number. Okay, so let me go ahead with the story and then I will decode it for you. So what you have to imagine is that as you go from left to right side of the racks, you will find that number of rings are same. So in the second rack, you start from left to right, number of rings are 2. In the third shelf, start from left to right, number of shelves or number of rings are 3. Then 4, 5, 6, 7, like that. And number of rings increases as we go down the shelf. Number of rings is 1 in the first shelf, then 2, 3, 4, 5, 6. So you see number of rings of the item goes on increasing down as you go down from 1 to 2. Then you have to remember for the size. How will you remember for the size? And that we will relate with the size of the atom. As you move from left to right, you remember that size of atom decreases. The size decreases. It is because more and more number of electrons are added up. So as you go from left to right, number of electrons are goes on adding. Number of rings remain the same, but number of electrons goes on adding. So when it goes on adding, nucleus will become strong and it will pull up inside. So what will happen to the football as you remove the air from the football?
It will shrink.
Will it increase the size or decrease the size?
It will shrink, sir.
What will happen to the football?
Sir, it will decrease the size.
Decrease. In the similar fashion, you imagine that there are footballs kept, and as you move from left to right, the slowly air is coming out. When the air is coming out, the size decreases. And when you move from top to bottom, what will happen to the size? Size will increase or decrease?
Increase.
Naturally, yes.
It will increase, sir.
It will increase because number of rings are getting increased. So you have to remember it like this regarding the atomic size. Then you have to remember one more thing. So you have to remember regarding metals and non-metals. So in these racks, metals are kept, non-metals are kept for sale. You imagine that it is a supermarket, and if you want to buy metals, you will find them on left hand side. If you want to find non-metals, they are kept on right hand side. And the third type of metals are called as metalloids, and which are having half the characteristics of metals and half the characteristics of non-metals. And these are kept in zigzag manner. So next part of the story is metals are kept on the left hand side, non-metals are kept on the right hand side, and metalloids are kept in zigzag manner at the center. That I will tell you later on how to identify that. This is the part of the story. Then, so when we see that on the left hand side, metallic characteristics are more. So, and on the left, as we go to the right hand side, the metallic characteristics become less and less and less. So you imagine that metallic characteristics decreases from left to right. That is left to right. And metallic characteristics decreases from top to bottom. So fewer or good metals are there on the top, and lesser metallic properties are there on the below. So you have to imagine regarding the metallic characters. So metallic characters is more towards the left and less towards the right. Metallic character is more from on the top and less at the bottom. So this is regarding the metallic characteristics. And then these electrons are there. What is the tendency that they will lose? As you go down from top to bottom, electron become loose because it is far away from the nucleus. So they tend to lose more. So on top, tendency to lose the electron is less. At the bottom, as we go down, tendency to lose the electron is more. Then tendency to lose electron at the first case. What do you think? Here there is more tendency to lose, and here there is no less tendency to lose, because as I have told you, here nucleus is strong and it will attract or hold more electrons. Here less tendency to lose, here more tendency to lose. And on top to bottom, less tendency to lose and more tendency to lose. So these things you have to keep it in mind. Now let me decode it, and then I will send you the notes of this decoded thing. So this was a story, and with this story, let me decode it. The first decoding, there are 18 racks. Those are vertical columns, and vertical columns are called groups. So 18 vertical column, they are called groups. So how many groups are there? Total 18 vertical groups are there. And seven shelf corresponds to the period. They are called period. And how many periods are there?
7.
7 periods are there. So from this diagram, you remember that there are 18 columns called groups, and there are 7 horizontal rows. Those are called as the period. Then the next decoding is all elements in particular column will have same valence electron, same number of valence electrons as we go down. So I have told you here that first shell will have 1 electron in the outermost shell. So here in the outermost shell, there are 2 electrons. So valence electron will remain the same in the column as we go down. So this is one interpretation. And the next interpretation is in period. And period are nothing but the horizontal shell. In period, number of shell remains same. So you see, you go across the period, here there is only 1 shell. In second period, there are 2 shell. In the third period, there are 3 shell. Okay, so but in each period has got same number of shell, but number of shell increases as we go down. So the next point is here in period number of shells remain same, and number of valence electron increases by 1. As you go down. Okay. Then next. Then next is maximum number of electrons is given by 2n square. Then about chemical reactivity. About chemical reactivity, you come to know from the position of elements. Depending on position of elements, you come to know about the chemical reactivity. Then about valency. You know what is valency. Valency is number of electrons in the outermost shell. Now you have to tell about the trends. So first is atomic size. Atomic size or atomic radius, both the same. So which is having the least atomic size? So please refer to the periodic table there. Open your textbook and refer to the modern periodic table. The trend I am telling you now. About first is the atomic size. what happens to the atomic size? As you move from left to right, and then from top to bottom, here this increases or decreases? I have told you, as you move from left to right, number of electrons are getting added up. In the outermost shell, here there will be 1 electron, here there will be 2 electrons. Here will be 1, 2, 3, 4, 5, 6, 7, and 8. So as the number of electrons increases, the nucleus becomes strong and it will attract the electrons inside. So the size decreases as we move from left to right. So size decreases from left to right. Remember that size decreases as you move from left to right. And the reason is, what is the reason? Strong nucleus. And strong nucleus, more attraction to electron. That's why the size decreases as we move from left to right. What happens to the size as we move from top to bottom?
Sir,
See,
increases.
increases because number of rings are getting added up. So this is increased. Reason is what? Number of shells are added every time. Are added by 1 every time. These reasons are asked in the examination. So please remember this trend. The first trend is regarding the atomic size. Then the next trend I will discuss here is regarding tendency to lose electron. So here is a tendency to lose electron. So first I will discuss from left to right and then from top to bottom. So this tendency decreases. The reason is the nuclear charge is more. On valence electron decreases. And then from top to bottom, what happens to the tendency? Does it increase or decrease? Tendency will increase because there will be less control over the electron by the nucleus. So it increases. Electron become more and more loose. So it can lose very easily. So tendency to lose electron from top to bottom increases. So this is the trend regarding the losing of electron or tendency to lose the electron. The third trend is metallic characteristics. So it is metallic character. So what happens to the metallic character from left to right and from top to bottom? As I told you, on the left, metallic character is more and on the right it is less. So it is decreased from left to right and from top to bottom also. On the top, metallic character is more and less at the bottom. So here also it decreases from top to bottom. So this is regarding the metallic characteristics. And then you have to know what is called as electropositive and electronegative. One is called as electropositive elements. The second one is electronegative elements. When compounds are formed, some are called donor and some are called the acceptor. So you have studied metals and non-metals. Which are the donor of electron? When metals gives it, then it gives out negativity. That is, electrons are negative. When negative goes, what will happen to the positive? Positivity will be more. So it becomes electropositive. When electron is given out, that is donor, that is the metals. Electropositive elements are metals because they are the donors and they donate negativity. So when they donate one negative electron, the net charge will become positive because it is having more positive. Before donating, they are neutral, equal amount of positive charge, equal amount of negative charge. The moment it gives out electron, more amount of positive charge will be there, and it is called as electropositive elements. And electropositive elements are metal. That is, they are all donor. And non-metals are electronegative. So because they are receiver and they receive negative electron. So that means net negative charge on them increases, and that's why they are called as electronegative element. So when you are asked about the trend in, let's say, electronegativity or electropositivity, so here non-metals are electronegative because they form bond by gaining electrons. So electronegativity is more from left to right or right to left. Is towards right, right?
Yes,
Because the
sir.
right hand side are the
Non-metals.
non-metals. So electronegativity is towards the right. And top of table are more electronegative. And electronegativity decreases down. So that is about the metallic characters, that is electronegativity. Same thing can be written for metals, which is electropositivity. Mostly you are asked to quote about the electronegativity. These are the trends which you have to remember. So we had discussed, yes, there are presently 118 elements known to us, and out of these 94 are naturally occurring elements. Around the year 1800, only 30 elements were discovered. So this was the first point that I told you that I will be discussing, and there will be total 6 points that I will be discussing. The first point is this. The second point is Mendeleev's periodic table. Mendeleev arranged the elements on the basis of their fundamental property, the atomic mass, and similarity of chemical properties. He worked on compounds formed by elements of hydrogen and oxygen. This point you have to remember. He works on the compounds of hydrogen and oxygen, so that he found hydrides and oxides of these elements. So, and he studied based on hydrides and oxides, and he observed that there occur periodic recurrence of elements with physical and chemical properties. Periodic recurrence meaning after every certain number of items or elements, its property is to get repeated. So that is called periodic occurrence. So that is regarding the Mendeleev's periodic table and the law. Normally you are asked to state the law for Mendeleev's periodic table. Just like the law we have said for the modern periodic table. There it was atomic number, here it is atomic mass. Only this difference is there. Rest of the words in the statements are same. The properties of elements are the periodic function of their atomic masses. And in modern periodic table, it is the properties of elements are periodic function of their atomic numbers. So this is Mendeleev's periodic table. And after Mendeleev's periodic table, we will understand more about this one. Mendeleev's periodic table consists of vertical columns called groups, and vertical columns are called groups in the modern periodic table also. It is same thing over there and here. And horizontal rows are called the periods, similar to the modern periodic table. Now, Mendeleev arranged elements on the basis of their fundamental property, the atomic mass, and similarity of chemical properties. He worked on the compounds formed by elements with hydrogen, oxygen. Just now we have discussed this point. And the formula formed by hydrides and oxides were treated as basic property of their elements. And it is observed that there occurs periodic recurrence of the elements with the physical and chemical properties. This same thing law is stated again here. At two places it is said here the law is stated, and here also law is stated. What are the achievements of Mendeleev's? For Mendeleev, there are many achievements. One of them is elements with slightly greater atomic mass were placed before lower atomic mass. So for example, actually they should have been placed with the increasing atomic mass, but they found a place with greater atomic mass below the lower atomic mass for their similar property. And the example are cobalt, which is having atomic mass 58.9, were placed before nickel, which is having less atomic mass, that is 58.7. Then this second point again is important because he left some blank gaps in periodic table, and his name is as Eka. Eka meaning in Sanskrit it is one. So example, scandium, gallium and germanium. So he left blank and named as Eka boron, Eka aluminum and Eka silicon. And later on, this Eka boron was replaced by scandium, Eka aluminum is replaced by gallium, Eka silicon is replaced by germanium. So let me go to next page. So 2 points we have discussed, that is advantages or the main points of Mendeleev periodic table. The first one is that atomic mass with a higher number is placed below the atomic mass with lower number. The second point we discussed about the advantages of Mendeleev's periodic table is that he left some blanks, and later on, when these elements were discovered, they found the place. The third point is when noble gases were discovered like helium, neon, argon, they were placed in the same group without disturbing the existing order. These three were the points of Mendeleev periodic table. And this you see here, groups and period are shown over here. This is Mendeleev's periodic table, which you can see. Then we will see what are the limitations of Mendeleev periodic table. There are three limitations of Mendeleev periodic table. The first one is that he could not assign correct position of hydrogen in this table. So that was the first disadvantage. The second disadvantage is that, or limitation, regarding the isotopes. Isotopes which were discovered later. What is isotopes? Yes, same atomic number, but their properties are different. Physical properties are different. Those are called as isotopes. And these isotopes which were discovered later, they pose challenge to Mendeleev's periodic table. So this was the second limitation of Mendeleev. The third limitation is atomic masses do not increase in regular manner. We have seen some found below the lower atomic mass number. So it was not possible to predict how many elements could be discovered between the two elements. And these three challenges were there faced by Mendeleev's classification. And to overcome these three challenges, or these three challenges are overcome by the modern periodic table.
We at eLearning Career Academy are running classes for standard 9 and 10 in maths and science, and also for standard 11th and 12th in physics, chemistry, mathematics and biology in offline as well as online mode using memory techniques. Here are the links for joining these classes. These links are also given in the description of this video.